Welcome to the DIY Honda Garage channel. Welcome to this presentation on DTC P0103, which indicates a mass airflow sensor circuit high voltage condition in the Honda Accord models from 2012 to 2017. The MAF sensor plays a crucial role in measuring the intake air volume, which is vital for optimal engine performance and fuel efficiency. Its location is in the intake air passage, directly situated upstream of the throttle body. The MAF sensor operates using a hot wire airflow meter, meaning it determines airflow by measuring the cooling effect of the air passing over a heated wire. When the measured voltage from the MAF sensor exceeds a specified upper limit, the Powertrain Control Module, PCM, registers this condition as a malfunction, resulting in the DTC being stored. Understanding this error is essential for effective troubleshooting to ensure the vehicle operates correctly and efficiently. Preventive maintenance is key to ensuring the continued functionality of the mass airflow MAF sensor and the vehicle as a whole. One effective maintenance practice includes regularly cleaning the MAF sensor to prevent accumulated debris from affecting its performance. In addition, routinely inspect the air filter for blockages, as a dirty filter can restrict airflow and send incorrect signals to the MAF sensor. Checking for air leaks in the intake system is also crucial, as any leaks can translate into erroneous readings affecting engine performance. Implementing these preventive measures can greatly reduce the likelihood of DTC P0133 and related issues from arising, thus promoting efficient vehicle operation. In conclusion, understanding DTC P0103 is essential for maintaining optimal engine performance in the Honda Accord from 2012 to 2017. The mass airflow MAF sensor is critical for accurately measuring intake airflow, and any fault that triggers a high voltage signal indicates underlying issues that must be addressed immediately. A series of thorough inspections, including checking connections, testing the sensor voltage, and confirming PCM functionality, are necessary to diagnose the issue effectively. By being proactive with preventive maintenance, such as cleaning the sensor and inspecting air filters, car owners can mitigate the chances of encountering this DTC in the future. Knowledge and continuous monitoring are vital for sustaining vehicle health. DTC P0103 pertains specifically to the mass airflow MAF sensor, which measures the quantity of air entering the engine, crucial for the PCM to adjust fuel mixture and timing. The sensor is fitted in the intake air passage, placed to accurately gauge the airflow before it reaches the engine cylinders. It uses a hot wire meter technique, where the wire's temperature is manipulated electrically. The PCM then evaluates how much current is needed to maintain the wire's temperature under varying airflows. Once the voltage signal from the MAF sensor reaches or exceeds 4.89 volts for a duration of more than 2.0 seconds, the PCM perceives this as an abnormal escalation and triggers DTC P0103. This malfunction results in the activation of the malfunction indicator lamp, MIL, and may hinder the vehicle's overall efficiency if not resolved promptly. There are several potential causes for the activation of DTC P0103 that technicians must consider during diagnostics. One possible issue could be an open circuit in the variable geometry motor VGM line associated with the MAF sensor. This could prevent proper voltage transmission to the PCM. Another significant cause could be a direct failure of the MAF sensor itself. Given that this component is essential for accurate air mass measurement, any malfunction will directly influence engine operation and performance. Lastly, an internal failure within the PCM can also lead to erroneous high-voltage readings. Each of these causes needs to be evaluated to determine the source of the problem reliably. When DTC P0103 is present, several symptoms may manifest, hindering vehicle operation. Drivers might experience noticeable engine performance issues, including lagging acceleration and overall sluggish behavior, as the engine struggles to receive the right fuel-air mixture due to erroneous readings. This aspect also correlates to poor fuel efficiency. As the MAF sensor fails to provide accurate readings, it can lead to overcompensation of fuel, wasting gas. The illumination of the malfunction indicator lamp is almost a guarantee with this DTC, serving as a clear warning that maintenance is needed. Unstable idling may also occur as the engine control system attempts to adjust to misleading airflow data, creating fluctuations in engine speed. The first troubleshooting step for addressing DTC P0103 involves verifying the conditions under which this DTC was set. Begin by ensuring the ignition switch is in the on position, which is vital for enabling the vehicle's electronics and initiating diagnostics. It's also essential to check for any active diagnostic trouble codes that may conflict with the MAF sensor circuit. Additionally, confirm that the powertrain control module (PCM) settings are correct, as erroneous configurations can complicate troubleshooting. By establishing a baseline of operating conditions, you can accurately diagnose the system without external interference, leading to misleading results. The second troubleshooting step involves a thorough inspection of the MAF sensor connections. Check the wiring harness for any signs of wear, fraying, or damage, as these can lead to intermittent faults or disconnections. Any degradation may cause inconsistent voltage readings, misunderstanding airflow conditions. Also, verify that all connections to the MAF sensor are secure. Loose connectors can lead to voltage drops, ultimately triggering the DTC. Inspecting for corrosion at the connectors is also critical, as this can impede electrical flow and lead to further complications. Maintaining a pristine connection will help either eliminate or confirm the MAF sensor's integrity. For the third troubleshooting step, utilize a multimeter to test the output voltage from the MAF sensor. This gauge will help ascertain if the sensor is providing the correct voltage signal to the PCM. Ensure you measure the voltage while the vehicle is in operation to get a real-time reading. The expected output should be within the specified limits by Honda's standards. If the output is as high as or fluctuating above the 4.89 volts threshold, the sensor is likely malfunctioning. Compare your readings with the specifications provided in the diagnostic data, as this direct correlation is critical in determining whether to replace the MAF sensor or address additional circuits. The last troubleshooting step requires you to evaluate the functionality of the powertrain control module, PCM. Any internal circuit failures within the PCM can lead it to misinterpret or mishandle data from the MAF sensor, resulting in inaccurate voltage readings. Use a diagnostic tool to check for faults and ensure the PCM software is up to date with current specifications. If there are errors, they may require reprogramming to reset the system. This step is crucial, as it verifies the central control unit's performance and helps rule out any misinterpretations that could lead to recurring DTC P0103 codes. After completing repairs related to DTC P0103, it's essential to conduct a final verification process to confirm that the issue is resolved. Start by clearing any diagnostic trouble codes from the PCM, which ensures that the system is reset and ready for testing. Subsequently, perform a test drive to assess if the powertrain operates without any diagnostic codes reappearing during normal driving conditions. It's important to specifically monitor for any recurrence of symptoms, such as irregular engine performance or MIL illumination, which would indicate that further diagnostics may be necessary. This thorough final verification process is critical for ensuring the reliability and longevity of the repairs made. Please like and subscribe to the channel. See you next time.